And there's nothing special here about R2. I can do this same thing for R3, for example. Let's consider R3 now. So now we're in 3 dimensions. So we have X, Y, and Z axes. And so now I'm going to have 3 standard unit vectors, one pointing in the positive direction in each of the axes. So let me just add some tick marks here. So the vector pointing in the positive X direction, notice this vector is very similar to vector I before, right? So the standard unit vectors in R3 So the first vector, it's pointing in the positive X direction, so the vector will be 1, 0, 0. And we actually give it the same name as the comparable vector in R2. We call it vector I. From context, we will know whether we're dealing with R2 or R3, and whether vector I is just those first 2 components, 1, 0, or if we're in R3, it'd be all 3 components. Right? So generally, there's no ambiguity calling this vector I also. It is also pointing in the positive X direction. It is a unit vector pointing in the positive X direction. Similarly, the unit vector pointing in the positive Y direction, we again call vector J. And it has component 0, 1, 0. And we have one new vector pointing in the positive Z direction. If our first 2 vectors are called I and J, you're probably not surprised that this last vector will be called vector K, with components 0, 0, 1. So these are the standard unit vectors in R3. And just like in R2, we can express every vector in R3 as a linear combination of vectors I and J and K. So let's let vector W equal 2, negative 3, 5. Then vector W, which is 2, negative 3, 5. Another way I could write that is 2 times 1, 0, 0 plus negative 3 times 0, 1, 0 plus 5 times 0, 0, 1. Right? And of course, 1, 0, 0, 0, 1, 0, 0, 0, 1, those are the standard unit vectors. So I can express this as 2i plus negative 3j, or minus 3j, plus 5k. And so vector W is expressed as a linear combination of the standard unit vectors I, j, k in R3. They are a sum of multiples of I, j, and k. I have 2 times I have negative 3 times j, I have 5 times k, and then I add them together. And so that's a linear combination of the vectors I, j, and k.